All right, as promised, this is our calculator section where we're going to use the TI-84 to graph each of these. It's possible for you to go in your calculator, press y equals, and then recognize that you are in y's. Well, that's a mode. You can actually change these to be r's so that you can graph. So if you go down to, where does it say? Mode, function, go over to polar and press enter, second quit. You're going to be able to press the y equals, and it's no longer going to be y. It's going to be r's. So if you write 4 cosine theta and press graph, you will now see a flat-looking squished circle. The reason why it's flat is that you have 10 to the right, 10 to the left, 10 up, and 10 down. You can see that it's a little bit more squished on the y-axis. So you can press the zoom button and go to square, and that makes it a little bit better. And you can see that's a nice, perfect little circle. So when you look at that, you could recognize, oh, I know what the center of that circle is. It is 2, 0, and I know that it's got a radius of 2. So that actually can be easily written like this. Okay, let's try the next one to see if it can help us connect every one of these. So if we were to go over here, change this up, and write r equals 5 divided by sine theta, which you can't really, well, yeah, you can't really write cosecant. We're not going to stress about that. So when you press graph for that, like we said, this was a y equals 5 line, and it is. Moving to the next one, r equals 5. So if we go to this, press y equals, change the r equals equation to r equals 5, and press graph, we're going to see a circle that has a radius of 5 and centered at 0, 0. I'd like for everybody to look at the window, though. If you press the window, you're going to notice that you have an extra bit of information there. There's x min, x max in the scale, and then y min, y max in the scale. But what's important here is the theta min and theta max. So the lowest value that theta is here is 0, and the highest is, that's 2 pi. So if we just change this up real quick to theta equals pi, when we graph, we're only going to see half of that circle. So sometimes it's important for us when we're graphing things, in particular, like the roses that you saw yesterday, if we're graphing 5, I don't know, sine of 3 theta, and we press graph, what you might not recognize is it actually went over that twice. If we go to our window, and it would go over it twice if we had it as that, okay? And so it's important maybe to just recognize I could have just left it at pi, so the life of that one is pi. The important newsflash, the life of pi. Let's talk about that. What would actually complete a circle or complete a graph if it was a life of pi? So when we press graph and we see this, if we ever have an odd amount of petals on a rose, that has a life of pi, like the book or the movie. There's another one that has just a life of pi, and that is when you have a circle that is centered off one of the, is hugging one of the axes. So this has a radius of 3. We press graph, we're going to be fine, okay? Now, every other graph that you are supposed to know, like the lemniscats, actually, you don't think you need to know lemniscats, but the lemniscats and the cardioids, the circles that are centered at 0, 0, they actually have a life of 2 pi. So if I were to do, let's do 2 plus 2 sine theta, that's hugging the positive x-axis. Because I only went to pi, it's not going to show me the whole cardioid. So 2 pi is going to show me the full-on cardioid with the little bumps on the bottom. Okay, if I want to make it look like a heart, go over here and just make this negative. Or minus, excuse me. That's division. That's not what I want. Minus. Oh, happy Valentine's Day. Let's move along. All right, theta equals pi over 6. This is one that you cannot graph because you are required in your calculator to give an r equals equation. And this is a theta equals equation. So we just have to know that it will create a line and follow the steps there. For this one, we know that this is centered at, well, let's just graph r equals 2. and see what it looks like. It looks like that. That's exactly what it should look like. X equals 5, I can't really graph. Oh, I guess I can. I guess, never mind, because I'm graphing the polar. So I can go back one step to this and graph that, and that gives us a vertical line at x equals 5. Let's try this crazy one. This is supposed to be a line. It's in standard linear form. So we would type in 5 divided by parentheses 2 cosine theta plus 3 sine theta. Graph. Yep, that is that line. It did graph really weird, but that's the line. All right, the last one that we have, this is going to kind of look weird. For some reason, it doesn't come out the way that I wish it would, but we're still going to type it in and see what it shows. It's 6 cosine theta plus 4 sine theta. Okay, please graph correctly, or kind of. Oh, it actually graphed really nice. Okay, so some calculators might have a weird wonky looking circle, but this one is centered at 3, 2, and it has, I don't know, whatever the radius of square root of 13 is. That's what the radius is. Very nice. So now you have some time to work on converting these for your final step for your wrap up today. So take a second to finish it out so you can feel very confident in what you're doing. All right. Answers for the wrap up. X equals 5. X squared plus y squared equals 36. O number 3. X plus 3 squared plus y minus 2 squared equals 13. For number 4, r equals 4 over sine theta. Oh, which is cosecant. I should have put that. Number 5, r equals negative 5 secant theta. And number 6, r equals the root 5. And I guess I didn't do number 7. So that would be r sine theta equals 2 r cosine theta plus 7. If we bring that over, that's going to be r sine theta minus 2 cosine theta equals 7. Divide by that, and we get r equals 7 over sine theta minus 2 cosine theta. So much fun. All right, guys. Enjoy the practice that we have for class today.